we can write change in velocity mathematically with an equation?
V minus u by t. V minus u by t.
Final volume minus initial volume by time.
So anything in motion stays in motion until an external force is applied on it. Okay. So let's talk about motion first. Obviously, when we have motion, that means something is traveling a certain distance over a certain time. Now, here, anything in motion stays in motion. That is in context of this motion being constant. Namely, it is moving over the same rate. That means it is moving at the same rate. It has a constant velocity. Does anyone here know what acceleration is? Anyone want to raise their hand? Sure. Okay.
Rate and change.
Acceleration is change in velocity. That is a pretty good definition. Does anyone have an idea of how we can write change in velocity mathematically with an equation?
V minus u by t. V minus u by t.
Final volume minus initial volume by time. So,
Final velocity minus initial velocity over time. Very good. So this can also be written as the change in velocity divided by the change in time. Now, let's think about it. If the object that we're talking about here is staying in constant motion, constant means no change, of course. Constant means no change. So, that means constant velocity would mean no change in velocity. And we can write this huge long phrase, change in velocity, is simply delta V. So, if there's no change in velocity, is there acceleration or not? Good. There is no acceleration. Think about it. If acceleration is delta V over delta T, and delta V is going to be equal to 0, there's going to be no change in acceleration. There's going to be no acceleration at all. So let's think about that. Okay, so do any of you know what momentum is? Because momentum is going to be the focus of this lesson. Do any of you want to raise your hand and talk about momentum? Okay, mass into velocity. That is certainly the equation, but that's not too much of a rigorous definition. Like if I asked someone what distance is and they told me velocity times time, I wouldn't understand anything. So what does momentum really stand for? So momentum is basically how hard it is to get something to move and how hard it is to get something to stop. But you were right, it is mass times velocity. At least that's the equation we use for it in kinematics. So, if momentum is mass times velocity, can anyone think of what the change in momentum would be?
mv upon del t.
Okay. Well, that is actually force, coincidentally, which we'll talk about later. But no, change in momentum is not mv over delta t. Does anyone have another idea? Oh, wow. That is a good definition. So delta t can be written as mv1 or v final minus v2, v initial. Alright, that is a good definition. delta P equals m delta V. So we have already determined that there is no change in velocity. So Vf minus Vi is equal to 0. So if this is true, is delta P equal to 0? Is there a change in momentum or not? There is no change in momentum. And that shows that in Newton's first law basically says that anything in motion will stay in motion when delta P is equal to 0. Also, think about it. When external forces apply, well, technically, maybe that's true, maybe that's not. For example, there's the converse of anything in motion stays in motion. Newton's first law also has a second part that says anything at rest stays at rest. Give me a second. Anything at rest stays at rest until an external force is applied. So, let's see. Not in applied, is applied. Okay. So if I am just holding this marker in my hand, would you say it is at rest or not?
Yes.
Alright. But it's at rest, right? So, if this is my hand, I know it's not a rectangle, but still, if this is my hand and this is the marker, there's the force of gravity acting on it, and then there's the normal force acting on it. So, there are two external forces on you, not 0, so why is it still at rest?
Forces are actually balanced.
That is pretty good. These two forces cancel out. So technically, the right word wouldn't be an external forces applied, but rather until the net force is 0. Now you might be asking, what does this funny symbol, sigma F, mean? Well, this stands for the net force, which is like the sum of all forces. Now these two forces, normal force and gravity, they cancel out. So here, net force is 0. So when external forces apply, we can rather say sigma F equals 0. So we have the net force equals 0 and acceleration is 0. Momentum is constant. Okay. Now can anyone tell me what before that, let's actually show an example of Newton's first law. Oh, here was this. Oopsies. Okay, so let's say we have a car. Can anyone give me a mass for the car?
500.
Okay, 50 kg, sure. 60 is just as good as a number, but 50 kg, okay. And let's say it's moving how many meters per second? Anyone want to give? Huh?
30.
30 meters per second. Okay, so if this is 50 kilograms and it's moving 30 meters per second, can anyone tell me what its momentum is?
I'm going to take the audience as much as possible.
Good. 1,500 Newton seconds. So that is momentum. But now let's think about it. This momentum is going to be constant, right? So if this momentum is constant, what does that tell you about our velocity? Okay, good. So if momentum is constant, our velocity is constant, which means that our acceleration is 0 by definition. Oh, so that's enough talk about law number 1.